You know, for as long as any of us can remember, science class has pretty much meant one thing: the physical lab. But what if the biggest breakthroughs in science education weren't happening at a lab bench at all? Today, we're going to look at a virtual revolution that's making science safer, smarter, and way more accessible than ever before. I want you to think back to your high school chemistry class for a second. Can you picture it? The smell of the chemicals, all those rows of glass beakers, and of course, that super long list of rules. Goggles on at all times, don't even think about tasting anything, know where the emergency shower is. It was exciting, for sure, but let's be honest, it was also kind of intimidating, right? And that whole traditional lab experience, as important as it is, comes with some very real and very limiting problems. So let's really dig into what those limits are. First, you've got the obvious safety risks with hazardous materials. Then there's the cost, which is just huge. The expense of building and maintaining a proper lab is astronomical. That alone limits how many students can even fit in the room, and it makes something like remote learning basically impossible. And what's the result of all this? Well, sometimes students end up focusing more on just following the rules than on the actual thrill of scientific discovery. Okay, so what if you could get all of that amazing discovery, but without any of the danger or the crazy costs? Well, that is the promise of the virtual laboratory, a lab that exists entirely in the cloud. So, what exactly is a virtual lab? Well, to put it simply, it's this immersive simulation where you can run all sorts of experiments in a completely safe digital world. The magic words here are anytime, anywhere, and without risk. You get all the hands-on learning, but with none of the physical barriers. And you know what that means? Unlimited do-overs, endless trial and error without consequence. And here is a perfect example of where these virtual labs just shine. You know, understanding the difference between a physical property, like ice melting into water and then freezing back into ice, and a chemical property, like wood burning and turning into ash, is fundamental. In a real lab, you can't exactly unburn the wood, right? But in a virtual lab, you can run these kinds of experiments over and over again, seeing the difference for yourself until the concept really, truly clicks. Now, this all sounds great in theory, but you might be wondering, how in the world does a simulation actually bring a chemical reaction to life on a computer screen? Let's take a little peek under the hood. It all comes down to the simulation engine. So first, you get these really realistic 3D visualizations that basically put you right there in the lab. Then, using interactive controls, you get to start experimenting. What happens if I crank up the heat? What if I change the concentration of this chemical? You get immediate, real-time feedback as the reaction happens, and the whole thing wraps up with instant analysis, showing you the data behind what you just did. It's the entire scientific process, all in one seamless experience. All right, so enough with the theory. What does this actually look like in practice? Let's take a look at the catalog from PraxiLabs, which is a leading platform in this space, to see the incredible range of experiments you can run. I mean, the variety here is just amazing. In chemistry alone, you can do everything from analyzing what's inside an aspirin tablet to actually synthesizing paracetamol, the active ingredient in Tylenol. And it's not just chemistry. You can hop over to physics and explore fundamental concepts like density and heat. The big takeaway here is that these aren't just textbook problems anymore. They're fully interactive experiments that let you finally bridge that gap between theory and practice. So, this brings us to the big one, the most important question of all. The tech is cool for sure. The experiments are diverse, but does any of this actually work? Is this an effective way to teach science? Well, let's see what the research has to say. And wow, the evidence is pretty compelling. This quote here is from a study that looked at future teachers using PraxiLabs. The key finding? Let's zero in on that phrase: a significant, positive shift in their attitudes towards science after using the platform. Now think about that for a second. It's not just about learning facts. This tool is fundamentally changing how the next generation of educators feels about science. That is a huge deal. But, the impact goes even deeper than that. The platform got high marks for being user-friendly and accurate, which naturally led to better learning and engagement. But get this, and this is probably the most fascinating part, using the virtual labs actually boosted student engagement when they later went into a physical lab. Because they could practice in a safe environment first, students showed up more confident and way better prepared for the real thing. So it's not a replacement, it's an incredible preparation tool. So, when you add it all up, we have a tool that makes science safer, cheaper, more accessible, and even more effective. Which really leads us to the big question, right? Is this the future of the science classroom? It might not be a complete replacement for that hands on, real world experience, but as a powerful tool to complement it,